Hello, this is Mrs. Huntley. This is Module 7, Lesson 1. You should be on page 1 of your new module. Lesson 1 is about the Pythagorean theorem, and your essential question for this lesson is how can I approximate the square root of an integer that is not a perfect square? Hopefully you remember the Pythagorean theorem. We studied it in detail back in December, and this is where we used our a squared plus b squared equals c squared. And it's for finding the missing leg of a right triangle. That's one of the uses of the Pythagorean theorem. And back in December, I had encouraged you all to memorize your square roots up to, I think we talked about 20. I don't know how many of you took me seriously, but in this particular module, we are not supposed to use calculators. So we need to be able to remember our square roots in order to do our work, in order to figure out the missing leg of a right triangle or figure out whatever equation they're asking us to figure out. So what I would like to do is move back to the inside front cover of your module, and we're going to create a square root table. So what I'd like you to do is get a ruler, hopefully one that has centimeters, and what I'd like you to do is along the left edge of your front cover, I want you to draw a line, a vertical line, that is 27 centimeters long. That'll go about from the top of your book to the bottom of your book. And then I want you to move your ruler over about 5 centimeters to the right. I'm approximating here. And you're going to draw another vertical line. Watch me first. And then I'll show you what the finished product is going to look like, and then you can draw yours. Now what I'm going to do is put my ruler right here, because at 1 centimeter intervals, I want to draw a horizontal line connecting my two vertical lines. What I'm doing is creating a table, and I want to make it nice and neat so that I can use it to record my integers and their perfect squares. So this is the start of my work. Let me show you what we're creating. This is my finished table here. I took a screenshot of mine when I was still at school. So you're going to have your vertical line going down, another vertical line, and then at 1 centimeter intervals about, you're going to be drawing those horizontal lines. Then take another line and draw it down the center so that you can separate your x's and your x squares. Does that make sense? I hope so. If you make yours 27 centimeters long, like I did mine, you should have enough space to record perfect squares going all the way to 24. So are we going to use the squares going that high? Possibly. Do I want you to memorize all of them up to 24? No, not necessarily. It'd be really helpful if you could memorize them up to 20. And if I'm being completely and totally honest with you, I am awesome up to 15. And then for some reason, 16 through 19, we don't use them as often. They kind of fall out of my head every so often. But 20, again, I'm back on. And I don't know 20 through 24 by heart, but it fit on the page, so I went ahead and included it. So go ahead, pause your video, and create your perfect square root table. And then when you're done with that, rejoin the video. I'm going to continue on with the lesson. Okay, so page 1. How can I approximate the square root of an integer that is not a perfect square? So let's take a look at the classwork that they want us to do. This top part, this is just reminding us of what we learned back in December. So our first right triangle, remember this little box in the corner here means that that's your 90-degree angle. Hopefully you remember the hypotenuse is across from your right angle. Your hypotenuse is your C side. It's always the longest side of your right triangle. Your legs, your A and your B side, are interchangeable. It doesn't matter which side you call A or which side you call B. So the way I set this one up, I called the unknown side B and the side I know A. So I'm going to say I'm using my A squared plus b squared equals c squared. So a squared 15 squared plus b squared equals 17 squared. I have my handy dandy square root chart right on the opposite side. So even if I haven't memorized them yet, I can say 15 squared is 225. And 17 squared is 289. And now I can go about solving for the unknown side here. So to solve for b, I'm going to subtract 225 from both sides of the equation. And yes, I'm going into the triangle. I didn't plan that very well. Surprising, being that this is the 5th time I'm recording this video because of all kinds of problems that I've been having. B squared is equal to 64. If I take the square root of both sides of the equal sign, b will be equal to 8. So this unknown side of the right triangle is 8 centimeters long. Hopefully this is ringing some bells for you and you're like, oh, I remember this from back in December. Now this one in the middle here, we've got all 3 sides of the right triangle, or of the triangle, I shouldn't say right triangle. We've got all 3 sides of the triangle. What are they asking us to do here? Because we don't have any missing side defined. What they're asking us to do is use the Pythagorean theorem to find out whether or not this is a right triangle. Remember, a squared plus b squared will equal c squared on every right triangle. If they don't equal each other, it's not a right triangle. So let's go ahead and set this up. Again, your c side is always going to be your longest side. So out of 9, 12, and 15, 15 is our largest number. So that's going to be my c side. A and b are interchangeable, so it doesn't matter how you set it up. I'm going to say 12 squared plus 9 squared equals 15 squared. 12 squared is 144. 9 squared is 81. And 15 squared is 225. When I add 144 and 81, I have a hard time adding across like that. I would probably stack it. I'd probably come over to the side here and write 144 plus 81 and add down. So 4 plus 1 is 5. 8 plus 4 is 12. Carry the 1, so 225. So I'd have 225 on the left side of the equal sign and 225 on the right side of the equal sign. It's true. So this is a right triangle, and I can draw a little square in that corner to show that that's the right angle. Okay, the last one, I'm doing the same thing. I'm proving whether or not it's a right triangle. So set it up. My longest side here is 8, so that's my C side. Why don't you go ahead and pause the video, set this up, and see if you got it right. Okay, so when you set it up, you find out that 65 is the left side of the equal sign and 64 is the right side of the equal sign. That is not true, so this is not a right triangle. Again, hopefully this is coming back to you and it's becoming more familiar. Example 1 is exactly like the first example that we did together. So what I would like you to do is go ahead and pause the video again, see if you can set this problem up and solve it correctly. I'm going to go ahead and do the same thing, and then you can check your work. Okay, I set it up as 5 squared plus b squared equals 13 squared. 5 squared is 25, plus b squared equals 169. Subtract 25 from both sides of the equation, and then you end up with b squared equals 144. Take the square root of both sides of the equal sign, and 144 is a perfect square, so b is equal to 12. So the missing leg here is 12 centimeters. Again, nothing's new here. This is just a reminder so far of everything we learned back in December. Let's take a look at the second example. It's saying it's a right triangle One leg is 4 centimeters, the other leg is 9 centimeters. So we're looking for the missing hypotenuse. We're looking for the C side here. So let's go ahead and set it up just like we did before. 4 squared plus 9 squared equals C squared. 4 squared is 16. 9 squared is 81. When I add 16 and 81, I get 97. 97. That's not ringing a bell as a perfect square. Let's look at our square root table. Okay, if I'm looking at my square root table and I'm looking for 97 somewhere here, there is no 97. But where would it fall if I were going to add it into this table? So looking here, 97 is greater than 81, but it's less than 100. So it'd be somewhere in this space. It's closer to 100 than it is to 81. So if I took the square root of 81, I get 9, and the square root of 100, I get 10. So the square root of 97 is somewhere between 9 and 10. It's closer to 10, so maybe it's like 9.8 or 9.9. I don't know. This lesson is just asking me to approximate it, so I don't have to know exactly. Actually, knowing just that it's between 9 and 10 is what this lesson is asking us to do. So you're probably thinking, so how do I write that answer? You write it just like this. The square root of 97 is not a perfect square. The exact length of the square root of 97 is somewhere between the square root of 81 and the square root of 100. Therefore, the side length of C is somewhere, oops, I spelled somewhere wrong, between 9 and 10. I also forgot my square root sign. Oh, I forgot that square. Sorry, I hope that didn't confuse anybody. And let me see if I can fix my misspelling. And I can't. Oh, I know why. Well, forgive me my misspelling. Somewhere is spelled Somewhere. And for some reason, I can't fix it. So hopefully that makes sense to you. Let's do another example together. Okay, same type of thing. We're looking for a missing hypotenuse here. We're missing the C side. So I've got 8 squared plus 3 squared equals C squared. Why don't you go ahead and pause the video and get as far as you can without me, and then come back and see how you did. Okay, so 8 squared is 64. 3 squared is 9. When you add 9 plus 64, or 64 plus 9, you get 73. Again, if I look at my table, oh, that is not what I meant to do. I can't believe I just erased that whole page. Okay, well, it's been a day. Okay, so 73. I'm looking for 73 here. It's not on there. 73 is going to fall somewhere between the square root of 64. It's greater than 64. It's less than 81. So the square root that I'm going to be looking for is going to be somewhere between 8 and 9. Go back to the page. I wonder if I can do. Okay, so here's example 3 again. I had some technical difficulties and I think I got them all straightened around, so I'm sorry if it jumped around a little bit for you. We set up the problem to be 8 squared plus 3 squared equals C squared. 64 plus 9 equals C squared. That's where I'm at. And when we add 64 and 9, we get 73. And we looked at our square root table, and we saw that the square root of 73 is not a perfect square. But the square root of 73 is greater than the square root of 64 and less than the square root of 81. Why am I picking 64 and 81? Because they're perfect squares. When I take the square root of 64, I get 8. And when I take the square root of 81, I get 9. So the missing side of this triangle is between 8 and 9. It's going to be greater than 8 and less than 9. Actually, 73 is closer to 81 than it is to 73. I can't speak anymore. 64. So we know that it's actually going to be a little bit closer to 9 than it is to 8. I'm going to conclude this lesson here because it's late, and I've recorded this lesson 5 times because of all kinds of technical difficulties, so I'm really tired. Just to summarize what we learned, we're going back over the Pythagorean theorem, so hopefully it reminded you of some of the things that we learned back in December. And perfect squares are numbers that are a product of an integer multiplied by themselves. For example, 25 is a perfect square because it's the product of 5 times 5. So when you're trying to determine the square root of a non-perfect square, you can estimate the length as a whole number by determining which two perfect squares the number is between. The example that we just did, 73 is between 64 and 81. 64 and 81 are the perfect squares, so I know the missing side is somewhere between 8 and 9. Our next lesson, lesson 2, is going to show us how to actually come a little bit tighter with our estimation. Instead of just saying it's between two whole numbers, we'll actually get a little bit closer and figure out maybe the fraction or the approximate decimal that it is. So I hope you have a good rest of your night. Thanks for watching, and I will see you tomorrow.